And one of the questions that people wanted to ask was, so a lot of the people who hear about machine learning, AI, and so on, what they think about is whenever they think about those words, they just think about, oh, okay, these are computer science aspects of it, and as a mechanical automotive engineer, it does not have any relevance for me. And similarly, there's the other side. When computer science engineers think about autonomous vehicles, they think about, oh, okay, this is more of a mechanical engineering aspect of it, or there is no need for a computer science engineer. So it is more interdisciplinary. And what are your thoughts on that? Like how can this program benefit like different types of engineers, and what are the prerequisites essentially?
Yeah. When it comes to data science or machine learning, I think it's a little dissimilar from other branches of engineering where you need a wide variety of skill sets, right? One of these skill sets is you need to have domain knowledge. You need to understand the business and understand, why we need machine learning algorithms for that business. The other part of it is, of course, having the capability to build these machine learning algorithms, right? So there are two aspects to it. The advantage that mechanical engineers have is that they understand the domain. They understand automotive engineering. They may understand, whatever application it is. They may understand civil engineering, electrical engineering, and they have a business sense of what problem needs to be solved. When it comes to computer science engineers, they have the algorithmic background to, learn a lot of these things pretty quickly and understand good practices very quickly. I don't believe anybody has all the skills required to be the unicorn data scientist or the unicorn, perfect engineer in this field. Uh, both engineers have their advantages, and I think a good data scientist needs to be capable of understanding business and also picking up the skills required to actually implement machine learning algorithms to be, what you call a unicorn data scientist. That's perfect for the industry.
Great. Hey, that's helpful. So to kind of summarize what Anirudh said, you that can be a single domain that you can be good at, and it can be either the building algorithms domain, or the subject matter knowledge of a particular domain. And if you kind of want to become a data scientist in any of these domains, the importance is to kind of understand uh, how the data that you accumulate in your particular domain can be used to analyze different patterns using algorithms, right? So would that be a correct way to summarize it?
Yeah, and also when you go about and analyzing data or building any algorithm, the way you go about doing that is you frame questions, right? You want to ask specific questions about your data, and then you explore the data to try and answer these questions. And you need a very good domain understanding to ask the right questions, because if you're not asking the right questions, you are not going to be a very good data scientist, or you're not going to do a very good job at data analytics, right? So that's the part. So if you are a good mechanical engineer, you know what are the right questions to ask, and then you have the machine learning background to basically be able to answer those questions with the data, and that's what makes you, a good data scientist.
So can you give me an example of say when you say you need to have the right background to ask the right questions? Can you give me an example of, okay, in a particular domain that you work, that you can kind of say, okay, this is what I mean.
Sure. Yeah, I mean, so for example, let's take one of these projects, right? So one of these projects is like understanding or predicting the battery life while the battery is, running in a vehicle. So you want to be able to say how many cycles will the battery run before it completely degrades and it's no longer useful for automotive purposes. So why do you need to be a good mechanical engineer or a chemical engineer for that, right? You need to understand what batteries are, how they function, what kind of data I should be collecting, from the battery while it's running to be able to make predictions on how long it will last. You need to you need to ask the right questions, like, uh, is there a dependence of voltage on battery aging, right? Does the voltage of the battery over its lifetime affect battery aging? Does the aggressiveness of the driver affect battery aging? And you need to know to ask these right questions, because if you're not asking these questions, you won't collect data pertinent to those questions, and you'll never be able to solve the problem.
I think we have one question from Anita. Anita was asking, what about the fourth project? Which domain language is required?
So the fourth project is, I mean, we will implement that in Python. When it comes to the project, the domain, I mean, it's going to be a lot about signal processing, right? So the way we will, so I wouldn't expect someone to have proper signal processing or controls background. That is not something that is, that is something I would expect. But what is required is a fairly good understanding of mathematics to pick up these concepts easily, right? Like you don't need to be capable of solving partial differential equations. That's not required. But you need to know that if I'm taking a partial differential, partial derivative of something, why am I doing that? What does it mean intuitively? So that you understand what you're actually implementing. So that's the background that you would expect there.
It totally makes sense. So, Anirudh, the next question was more about prerequisites. So, since this is about, say, for example, ML and AI, what kind of computing knowledge should someone who comes into the program have, and what kind of the domain knowledge should someone in the program have?
Yeah, that's a good question. So I can answer this question independently for the four projects because I think there is some variance as to what the background required would be.
Mhm.
So starting off with the first two projects, I think they're quite similar in nature as far as the background is concerned. So for the first two projects, ideally you want someone from either a mechanical engineering, a chemical engineering, electronics, electrical, someone who understands battery. When they read a research paper about batteries, they need to understand what the research paper is talking about, right? They need to have some intuitive sense for it. And when it comes to the machine learning side, I would not say they need to be an expert at machine learning, but they do need to understand, basics of, how you would implement maybe simple machine learning algorithms. So even if you have to implement more complex algorithms or understand the mathematics for more complex algorithms, you should have the basics set to be able to grasp that quickly and, cover the project in 3 months.
Say,
Uh,
for example, if I know Python, but I have not worked on machine learning models, but I have learned, I've worked on a few algorithms, building few smaller algorithms in Python. Would I be able to cope up?
Yes, you would. So as long as what I would say is if you are not great at the domain and not great at machine learning, you would not have enough time within 3 months to pick up both. But if you have a decent understanding of the domain and you have some understanding of machine learning, you will be able to pick up one of these, right? So it won't be possible to do both, but as long as you have a fair understanding of one of them, I'm confident you can pick up both within 3 months.
Great, great. And what about 3 and 4?
Yeah, sure. So when it comes to number three, I would say someone with some understanding of machine learning, especially time series analysis, doesn't need to be too much, but they don't require necessarily a mechanical engineering background. This could be a computer science student, electrical student, mechanical student, doesn't matter. But definitely some experience with implementing machine learning algorithms, especially for time series analysis.
Great. And what about 4?
Vehicle diagnostics from audio signal. So I would say this one is the most machine learning intensive projects, right? When it comes to number one and number two, those are more domain intensive, right? You need a better, understanding of mechanical engineering is probably more important. When it comes to number three, I would say it's one of the easier ones among this. So, even if you're new to machine learning, but you have some basic experience, you can definitely pick it up. In fact, number three is more of a hands-on project where you even collect the data from scratch, right? So it's a pretty cool project, right from data collection to implementation. But when it comes to number four, it's actually more intensive. We'll be implementing models all the way from linear models, tree-based algorithms. We'll be implementing RNNs, CNNs, and we'll be trying a bunch of different models to see which performs the best, to basically propose a methodology that works the best. Right. So number four is going to be the most machine learning intensive, and I think for that you should have some experience with implementing machine algorithms. Not a lot, again, I wouldn't say a lot, but definitely some mathematical intuitive background in machine learning.
Great. And then what about, so one of the next questions was what tools do the folks who are going to take up these programs need to have? What is a must have? What is a good to have? What is like, okay, it's fine if you don't have, you can come and ramp up.
Yeah. So when it comes to tools, I would say for all of these four projects, you should know Python. Learning Python from scratch, within this period, and implementing learning ML and implementing is going to be a tall task. At the very least, you should already have exposure to Python. For the first two projects, it would be great if you have some simulation background. It doesn't need to be, we will be doing it using GD Suite, the simulation portion of the project. I would not, you can pick up the tool, but you should have some simulation background to understand how simulation models are set up, and how they're typically run, so you can pick it up easily.
And when you say simulation background, you're basically saying what do you intend to say? Say, for example, if I'm using a Simulink model, or so there is a 1D, 2D, and 3D. So irrespective of what simulation, is that fine? Or say no, since GD is more of one D kind of thing, 1D simulation experience might be great. Like, what would be great to have?
Right. So if you have MATLAB Simulink experience, that's perfect. That covers it all. And I think most engineers, mechanical engineers typically are expected to have MATLAB Simulink experience. If they probably do have it. But if not, I would say it is fine. Regardless of whether the experience is in 3D simulations, 1D, that is perfectly fine. But they need to understand at least how simulations are set up. It would be awesome if the experience is in MATLAB Simulink. But if not, I'm not too picky about that. It is okay if the experience is in 3D simulations also.